Welcome back. This is the last of the lessons for this mini project or this mini course. And in the previous one, we learned how to publish the raw detections from our YOLO node. We had the YOLO detector node v3, and we went over all of the bounding boxes and we published them. And as I told you, this is very important. This is how actual computer vision pipelines work because our YOLO detector node 3 detects objects, but it's not supposed to do much more with them. It's supposed to just publish the raw detections so that other nodes can subscribe to this data, this information, and do something meaningful with them, like avoid collisions or follow the leader or follow the enemy or whatever. So today we're gonna implement a very simple node that will consume these detections and will do something with them. And because we don't really have a real robot to do something a little bit more realistic, what we're gonna do is that we're gonna just summarize or keep a summary of what we've seen so far, which actually is not so unreal. Like it's still realistic. You need to keep you also need to keep a database of events that have happened throughout the run of the robot. So actually, this mini node that we're gonna do today is actually helpful. Okay, so as usual, before I show you the code, let's run it. So I have a few windows here ready for us. Um, so you know how the steps, right? How to run this. You've been doing it for a while. So I'm gonna run the YOLO detector node 3, which will be ready to do the detection. And here I'm going to run the new node, but I'm not gonna. I'm actually gonna run it now. So this is the new node. And the new node subscribes to detections raw and says no detections received yet, right? Because we haven't played the ROS back, or in a real system, maybe the robot is still not fully active, the camera is not fully active. And here, let me see what I got here. Arvis is already running. No, it's not. So let's run Arvis. I want to have Arvis ready for us. So here, let me open recent configuration. Okay, I'm gonna close this one. A minute. Okay, and now I'm going to start playing the bag here, and we'll notice that the moment the bag starts playing and detections are made, and we'll visualize them here. The detection counter node will keep track of everything we've seen. So I run the bag and should start pretty soon. Unless, yeah, there you go. And then you see we've seen 2 bosses, 27 cars so far. It just keeps counting, right? Detection totals. So we've seen buses, cars, handbags, motorcycles, parking meter, person, truck, and we just keep track of them. And again, it's a very simple illustration of what you can do, but it's actually not too unrealistic. Like you should take a database of things you've seen. But other things that you can do by subscribing to the detection data is obviously avoid the object or follow it or anything else. But this is it. We're done with this mini project, this mini course, and we ended by illustrating how we would use the detections. Now let's not forget the code. So I'm gonna stop this because it slows things down a bit. Let's have a quick look at the code. So there's a new node. So far we've been working with YOLO detector nodes, right? 1, 2, and 3. Now this node is not gonna publish data, it's gonna subscribe to data. So here's the node. It's fairly simple. We're gonna subscribe to the detections raw, and we are just gonna read one time per second. We're gonna get the data 1 time per second or 1 hertz. And we're gonna have just a dictionary, which is the internal data. So we have a dictionary that is empty. We create the subscriber, and then we have just have a timer. This is just for debugging purposes. So this timer will print 1 divided by print frequency hertz is Here. Oh, my bad. Apologies. The subscriber obviously is not 1 times per hertz. It's just as soon as we get data. My bad. This is for the debugging. So we are going to print the summaries at 1 hertz pretty much, like 1 divided by 1. But we could make it faster if we were to increase this number. But right now it's once per second. And again, correction. Subscribers don't really have a frequency of getting data. They just get data as soon as data is available. If not data is coming, they don't trigger. If data is coming like at 100 hertz, they will trigger at 100 hertz. And by trigger, I mean they will call the callback. So my bad. Correction there. Okay, so once you have this timer that is for debugging purposes, the most important part is in the detection callback. Okay, so whenever you get a detection, and remember we are subscribing to a data type detection 2D array. Remember, it's what we've been creating here and publishing here. So we subscribe to that data, and then we just go over all the detections. Remember, we have a bunch of detections that we are appending to this list. So now we go over them, and if the detection has no results, we just keep that detection. Normally should have, and then we will get the results of that detection. That results will have a class ID, right, from the hypothesis. Again, you can see there's a hypothesis, right? There's a class ID, there's a score. Okay, so we are just extracting that data. So we extract the class ID, and then that will be the key to the dictionary, to the detection counts dictionary that we created here. Okay, and then I do self detection counts get class ID 0 or +1. So what this does, if you know how dictionaries work, is that it will get us the previous value or the previous count for this class. And if this class or this key didn't exist, if it's the first time we see this object, it will return 0. If we've seen this object before, it will return the actual count, and then we increase it by 1, and then we update it. Okay, so we are effectively counting how many times we've seen this object. And that's very much it. Pretty simple. And then for the summary, which will be printed once per second, as you can see here, we created a timer for it, right? So there's a timer that will call once at this rate, which is for now is 1 second, once per second. It will call the print summary, and then the print summary. So if the dictionary is still empty, we'll just say no detections yet and return. That's the end of it. But if the dictionary has something, it starts with this header. We will sort them so that it's consistent. Otherwise, every time we print it, it will look a little bit different. So we just sort it so that it's always consistent. As you can see here, it's always consistent. Bicycle, bus. It comes in alphabetic order, just for making visualization easier. And then we just go over the items in the dictionary, right? So we get the class and the count of the sorted dictionary, and just print it or show the output. And that's it. Here's just the main where we prepare everything. And that's it. With that, we have a pretty good example of how perception pipelines should work in ROS2. We start with data, either from a live robot or from a ROS bag. And then we have computer vision nodes or YOLO detection nodes that will extract detections from that data. And then we'll publish those detections as raw information, as raw detections. And then you can have another node that will consume this raw data and do something meaningful with it. And that's it. With that, we can call it a day. And I hope you have enjoyed this mini project, this mini course, and see you in the next one.